Now we're on to question number 20C, and this asks us to calculate, correct to one decimal place, the area of a triangle BCD. What formula should we use to calculate the area? Since we don't have a vertical height for this triangle, what we're going to have to do is, instead of using the formula a half AB, which we usually use when we have a vertical height for a triangle, we're going to have to use the formula half AB sine C to calculate the area of this triangle. So a half AB sine C. So let's look back and see if we can find any length. So we need two lengths and an angle to calculate the area. And do we have this from this triangle? Well, it seems no. There is another way that we could do this. As this triangle BCD is a triangle that's been cut out of ACD, we know that triangle BCD is equal to this bigger triangle ACD, subtract this other triangle ABD, this bigger triangle ACD. So I'm going to say that again. If we put together ABD and BCD, we'd get ACD. And similarly, if we subtracted ABD from ACD, we would get BCD. So we're going to use this here, this equation that we've come up with to calculate the area of BCD. The area of BCD will be the area of this bigger triangle I've highlighted in red, ACD, subtract this ACD, which I've highlighted in red, subtract this that I've highlighted or filled in purple, ABD. So using a half AB sine C. So for this, we know that AB are two lengths and sine C is the opposite angle, the directly opposite angle of the length we're not considering. So for triangle ABD and for ACD, we're going to have to find out the areas. But first, let's do it for ACD. So for ACD, we have lengths 12 and 15. We have lengths 12 and 15. That's for AD, length AD and length AC. And then we're not considering CD. So the opposite angle for CD is 30. So we have a half times by 15 times by 12 times by sine 30. And so the area of triangle ACD is a half times by 15 times by 12 times by sine 30. Sine 30 is also equal to a half, so we can rewrite this again as a half times by 15 times by 12 times by another half. And that comes to be 45 centimeters squared. So the area of triangle ACD is 45 centimeters squared. Now let's work out what the area of triangle ABD is. So using the same a half AB sine C, we're going to work out what our A, B and angle C's are for triangle ABD. And so first of all, ABD shares a side with triangle ACD, and that side is this side AD, which is 15 centimeters. We're also going to use this side AB. We could have chosen to use either this side AB or the side BD. And we can use either since it's an isosceles triangle, AB and BD are equal. And we know from the answer to part B that the length of AB is 8.7. I think it's best to work to at least 2 or 3 decimal places so that when we get our answer, it's correct to 1 decimal place. We're going to take AB to be 8.66. So the area of triangle ABD is a half times by 15 times by 8.66. And then we need to find out which angle we're using. So we're using these lines here as our lengths, AD and AB. So that means that BD is unused. The angle that's directly opposite to BD, is this angle here of 30 degrees. So that's times by sine 30 again. So what we get here is a half times by 15 times by 8.66 times by sine 30. And sine 30, as I mentioned before, is a half. So the area of triangle ABD is 32.482, so that's centimetres squared to 2 decimal places. So let's subtract the area of ABD from the area of ACD to get our answer. So that means that the area of triangle BCD is equal to 45 subtract 32.48. And that is 12.5 centimetres squared to 1 decimal place. So the answer to the question asks, what is the area of triangle BCD is 12.5 centimetres squared.